Om Swastiastu. Good morning, and before I start my presentation, let me introduce myself. My name is Tjokorda, and my student ID number is 22055311150. Here I will present Science of Engineering Materials about molecular weights of polymers and polymerization process. My reference is from Science of Engineering Materials books, volume 2, that written by Manas Chandra. Here is the table of contents of my presentation. First one, there is molecular weights of polymers. The second is definition of resin and plastics. The third is polymerization process. And the last one is the structural shapes of polymer molecule. Okay, first, molecular weights of polymers. In pure low molecular weight compounds, such as sucrose, all the molecules are of the same size and have identical molecular weights m. Such compounds are said to be monodisperse. In contrast, most polymers are polydisperse. That is, they consist of molecules of a range of size and molecular weight. Consider a sample of polydisperse polymers of total weights y, w, in which n equals total number of moles, and I equals number of moles of species I, comprising molecules of the same size. The tiny n I equals mole fraction of species I. The w I equals weight of species I, and the tiny w I equals weight fraction of species I. And the last one is the mi equals molecular weights of species I. Definitions of resins and plastics. Resins are vegetable-derived organic products with relatively high molecular weights, the most famous of which are resins and balsams, obtained from conifers. However, the term is now used much more broadly and somewhat loosely to include man-made polymeric substances used in a variety of applications, such as in plastics, textiles, and paints. The term plastics is also used in classifying polymers and includes all polymers which are not considered to be elastomers or rubbers, and fibers which show neither the elastic properties of elastomers nor the high crystallinity and strength of fiber. Polymerization processes. The processes of polymerization are divided into two groups known as steps polymerization and chain polymerization. The step polymerization is occurred by stepwise reaction between functional groups of reactants. The reaction leads successfully from monomer to dimer, trimer, tetramer, pentamer, and so on until finally a polymer molecule with large dp is formed. The example, the N-mer plus monomer, it will be N plus N-mer, and the N-mer plus M-mer, it will be N plus M-mer. Chain or addition polymerization is processed by a mechanism distinctly different from step or condensation polymerization considered above. Chain polymerization involves three processes, namely chain initiation, chain propagation, and chain termination. A fourth process, chain transfer, may also be involved. It may be regarded as a combination of chain termination and chain initiation. Structural shape of polymers molecules. Polymers can be classified on the basis of structural shape of polymers molecules as linear, branch, or cross-linked. Schematic representation of these types of polymers are given in figure. Schematic representation of linear is A, branch is B and C, and cross-linked is D and E polymers. The branch points and junction points are indicated by heavy dots. Polymers for use as textile fibers are linear polymers. However, they must satisfy two additional requirements, namely high molecular weight and a permanent orientation of the molecule parallel to the fiber axis. It is essential that the molecule have a high degree of order and a strong secondary force to permit its orientation and crystallization. Okay, this is the end of my presentation. So that's why I will say thank you. Om Santi Santi Santi.